Hello, today we are going to try to sit 4 people around a table. How many unique ways can 4 people be seated around a round table? By the way, all of the graphics and pictures are either mine or they're from the Microsoft 365 library. Well, we're not going to use very much math, a very little bit. We aren't going to use any equations or any symbols. We really want to see how open-minded you are. Watch all the way through to find out. All of these configurations are considered the same because each person is sitting with the same person to their right, to their left, and across from them. In other words, it does not matter who is facing the window or who is closest to the door, just where each person is relative to the others. There are 2 ways to use this fact, and it depends upon how you look at it. So the first method is we take our 4 people and ask them to line up. How many ways can they line up? To answer that question, we will look at our 3 old friends who show up frequently in how many questions. We have a deck of cards, a coin, and a die. If we pick a card, flip the coin, and roll the die, how many combinations? Well, there are 52 cards, and for each of the 52 cards, the coin might come out in one of 2 ways, and then for each of those 104 combinations, the dice might give us any one of the 6 numbers, giving us a total of 624. Back to our lineup, we have 4 people who could take the first spot, but then there's only 3 left, so it must be one of those 3 to take the second spot. The remaining 2 can be in the third spot, but by the time we get to the last spot, there's only 1 person. 4 times 3 times 2 times 1 equals 24. But wait a minute, quite a few of these configurations are actually the same, because each person is sitting in the same location relative to the other 3 people. We mentioned that before. So to help us along, I've grouped the identical ones into groups of 4. Let's look at the third block. Starting with the 6th position, we'll start with the first line and we'll put C in the position of the 6 and we'll go counterclockwise. So it's C, B, D, and A. The next line gives us A, C, B, and D, D, A, B, D, A, C, B, and B, D, A, C. And as you recall, we said that all 4 of these are equal. Since the blocks of 4 are equivalent, there are only 6 ways to seat the 4 people. That knocks it down quite a bit. Now, let's move on to the other way of looking at the situation. Instead of saying that the first person has 4 choices of where to sit, one could say is that they only have 1 choice. You see, no matter where they sit, who's to their left? That place is empty. To their right, that place is empty. And across the table, empty again. So they really only have 1 choice, because no matter where they sit, they're going to have an identical situation. Now we come to the second person. They have 3 choices. They can sit with the seated person to their left, or they can sit with the seated person across from them, or they can sit with the seated person to their right. When the third person comes along, they will have 2 choices of where to sit relative to the other 2. And then the last person has to take whatever the remaining seat is. And so we have 1 for the first person, 3 for the second, 2 for the third, and 1 for the fourth, which is 1 times 3 times 2 times 1, which equals 6, and that's the same answer as we had before. Does the first person have 4 choices or 1 choice of where to sit? What do you think? And which did you find easiest to understand? For those who want to do the math behind this, here's 2 videos, and I will put the URLs in the description of this video so that you can check it out for yourself using each of the 2 approaches. Well, the next time you're sitting down with 4 people, To play a game, why don't you try to recreate all 6 combinations of how you can sit together? That might be more fun than the actual game is. Thanks for watching, and see you next time.